It's just a lot of fun. Bunny Poke is another example. This is actually one of the most popular open social apps on Orchid, another social networking site. It enables users to have a personalized 3D avatar that they can use to express themselves and interact with their friends. When Orchid opened up open social apps to Brazilian users, Bunny Poke, their rate of install instantly increased by a factor of 8. Since they used App Engine, they were able to handle that increased load effectively without having to scramble around and build more of a data center or cloud themselves. The last one I'm going to point out real quick is Pixverse. They made a really interactive open social apps, a couple of them, PixChat and PixWall. And they were one of the very first companies to use App Engine. And as you can see from the quote, we were really excited to see them get their application up and running so quickly. And this, again, ties back to why we created App Engine, to make it easy to start and scale your apps. So I want to touch on connectivity quickly. You saw the great explosion in wireless connectivity. This has been fabulous for users, but not so much for developers, because there's a lot of different mobile platforms out there. Some of them have different open parts, some have different closed parts. What we need is tools and standards, a platform open to everyone, carriers, manufacturers, developers, and especially users. It should be just like the web. So we invested in a project that we call Android. It's a completely open source, world-class, we think, mobile stack, top to bottom. It's part of what we call the Open Handset Alliance. It's a partnership of 34 companies that came together around developing this. And we hope that the mobile industry will embrace this open source stack for development purposes. Being best for the users is being one goal, and the other goal is to make your life easier as developers. And there's an introduction to Android this afternoon at 4, which is something you might want to check out if you're interested in Android development. So I'm not going to spoil too many interesting surprises there. So I've touched on client, cloud, and connectivity. Now I want to talk about a couple of quick things that touch on all of these areas. The first one of these is the Google Web Toolkit, which is designed to make development easier. And for that, I'm going to ask Andrew Bowers, the product manager for the Google Web Toolkit, to come up and do a quick demo and talk to you a bit about it. Andrew?
So you may have noticed two things so far. One, that we want to make development, and web development in particular, easier for developers. And two, we like things to be really fast. And so those are two things you're going to notice about Google Web Toolkit. Now, browsers these days are actually pretty capable in the things they can do. However, in order to take full advantage of that, you have to be a JavaScript expert, you have to know all the differences between the browsers, you probably have to have a lot of time on your hands to actually develop it. Alternatively, you could have a set of tools to help you out. That's where Google Web Toolkit comes in. Google Web Toolkit allows you to develop in the Java programming language. It then cross-compiles that Java source code into JavaScript. And this is highly optimized JavaScript for multiple browsers. So it tailors specifically to the browser that the user is using, and it does the fastest, most performant thing for that particular browser. So that means that you have to spend less time worrying about browser quirks, browser differences, and you can spend more time on building functionality for your end app and your end users. Now, this is plain old JavaScript. There's no GWT or Google Web Toolkit runtime on the back end. It's just plain JavaScript that can be served from any server. So that means that you don't have to have Java on your back end. You can be serving that from anywhere. Now, this approach provides two fundamental things. First, it provides productivity for a developer, because you get to develop in Java, you can create abstractions and very maintainable code. But then we're compiling, so it provides performance for the end user, so your end users don't suffer because of your development model. So if we can switch computers, I'd like to show you what that looks like. Can we switch over to the other computer? So productivity comes in a couple of places. So first of all, because we're developing in Java, we can use all of the existing Java tools that are out there. And there's some pretty fantastic tools. This is the Eclipse development environment, and it has a lot of things that make development easier. You have code navigation, you have refactoring. So this is something that's, I mean, it's just Eclipse, and it's been around for a while. But the nice thing is, if we want to refactor something, you know, I did web development for a long time, and I forgot that I was developing in Notepad or maybe VI, and you forget that you can do some of these things. So here I'll just change this to images, and I changed that method signature, and it was a lot quicker than the old copy and paste and going through my code and figuring it out. So that's a nice thing. Now, when you hear compile, you may think, does that mean that I'm going to have to compile my source code every time to see a change? Well, we wanted to make this as close to web development and JavaScript development as possible. So that's where something called the Google Web Toolkit hosted mode browser comes in. The hosted mode browser takes your Java source code, it runs it as bytecode in the JVM and the Java virtual machine, but it drives an actual web browser interface. In this case, because I'm on a PC here, it's driving Internet Explorer. That's the system default. So this means that you can develop here's a mail sample from the GWT distribution, and it's just a simple AJAX front end. There's no back end here, and it's showing you an AJAX app. This is actually Java bytecode that's running on the back end. What this means is that you can do some nice development work, and you can move along just as you would with JavaScript. So for instance, if we look down here at this contact label, maybe I want to change that. So I'm just going to go over here to my development environment. Here is where we're setting that name. Let's say I'll set it to Italian. I'm going to save. I'm going to go back over to my hosted mode browser, and I'm going to click refresh, just like you would in a web browser. And you can see that that's changed. Okay, that's kind of neat, but that's not too exciting, huh? But the nice thing is you can also debug. Because we're running, once again, Java bytecode, we can step through the code. So I'm going to go back down to this contact panel. And now I've set a breakpoint on the click listener for these links. So when I click it, you can see that Eclipse is saying something. So it's now jumped to the place in the code, and I can step through this code. I can inspect variables. So see, I'm inspecting variables down here, and I can actually see the underlying DOM structure that we're using right down here. And I can get it going again. And now the pop-up is shown up. So that's some of the nice productivity gains that you get. But we're also compiling. So the performance side of this means that we can do a lot of optimizations that you wouldn't do if you were writing code by hand. And you can develop in a more object-oriented and maintainable way. We can do dead code removal, things that you aren't using and you left in your code perhaps. We can do obfuscation, so shortening down names across your application to make the JavaScript download smaller. And we can also do a lot of performance optimizations like inlining. That means that we take your code, the compiler does multiple passes over it, and where possible, it takes method calls and actually inlines those where appropriate. So it will actually take method bodies and inline that into the area where you're calling that method so that you don't have the overhead of going and making a call. I'm going to show you an example of that. So I'm just going to close this down here. And I'm going to go to another example I have here. My hello.java. This is a very simple example, but very complex code. And all it does is it's going to open up an alert window that says hello world. Okay, that's pretty simple. I bet everyone here knows how to do that in JavaScript. Well, the person that wrote this apparently just learned Java, and they used all the Java features that they could to show off. So here we have an interface, which is phrase strategy, and a hello strategy class. Well, that implements hello. That's pretty useful. And the world strategy, that implements world. Wow, this is impressive. Now it gets really impressive with combinator, which is combining hello and world, and it's even using generic. It's pretty fancy, huh? This is a Java 5 feature. And then we have get. I'm going to skip that one, come back to it. We have get message, which is putting this all together. It's creating those classes and then combining them and returning returning that value. And then we have on-module load, which is the equivalent of main